All right, wonderful people, let's get started. So by the end of this lesson, you will be able to simplify square roots with imaginary numbers and solve square root equations with imaginary numbers and find the product of pure imaginary numbers. So what you need to know. So there are such things as equations. So this is like a quadratic. We have an x square. So x squared plus 1 equals 0. This has no real solution. So mathematicians defined imaginary numbers to represent their solutions. I'll go ahead and explain this with a graph in a bit. The imaginary unit is with this cursive I. It has a name, I just forgot what it is. And it's defined as the square root of -1. So again, I is the same thing as the square root of -1. Okay. And the reason why we call them imaginary numbers is, think of a number, let's say n, right? If I have, write it a little bit closer over here. So n squared, so what number can I square to get, say, -9? Now you might be saying 3, but I would tell you 3 times 3 is +9, not -9. So you might say, well, what about 3? Well, or sorry, -3. Well, that makes sense, because, wait, hold on a minute. -3 times -3 would be +9. So you would not be able to get -9. So that's why this is considered to be an imaginary solution. It's not necessarily a no solution, because there's kind of a solution, but like I said, I'll try to explain why we call it imaginary in a bit. So anyway, here we have pure imaginary number, and it's written in the form of a plus bi, or b times I, where actually in this case here, I don't think there would be an a, because it says pure imaginary numbers. So there is a part here, and that would be b. So b is the real number, and I would be the imaginary part here. So I'm going to go ahead and fix that. There you go. That's what it really should be. Because I was probably thinking of complex number in that case. All right, there we go. So that's the pure imaginary number. So we need to know how to simplify negative square roots. So here we have square root of -a. What I'm going to do is I'm going to break it down so that a and -1 are not together anymore. So -1 is a factor that makes a negative number. So just like splitting numbers apart yesterday when we were working with radical expressions or simplifying radical, yeah, same thing. So by separating them, we try to get a into a perfect square. We're trying to get perfect squares so that we can take the square root of those numbers, and they can become numbers on the outside of the radical. And lastly, we simplify the radical, remembering that the square root of -1 is equal to I. So again, I equals the square root of -1. Okay. So there's our rules again. Let's go ahead and practice on some of these. So -9. So I need two numbers that multiply to -9, and I want them to be square numbers if I can. So one square number I can do is, well, 9 is already a square number, so I'm going to go ahead and separate it from -1. recalling that the square root of -1 is I, I'm going to go ahead and take out square root of -1. But we can also take the square root of 9, which is 3. And this leaves it so there is nothing left in the radical. Well, there'd be 1 left, or 0. So square root of 0 is 1, and 3i times 1, it would basically just cancel out, leaving us with 3i. All right, number 2. Let's go ahead and move on to that one. So yesterday, or I should say in the previous lesson, I had you write down 20 of the first perfect square numbers. And if you were looking at that list, you might know that 196 is a perfect square number. So let's go ahead and I'm going to take out the I. So again, this square root of -1. And I'm going to take the square root of 196, which is 14. So we got our final answer of 14i. All right, moving on to the next one. We have the square root of -5. I'm not used to saying that, by the way. It's not something that I normally say all that much. But usually I'm used to saying the negative first, so sometimes I think I trip that up. So -1 times 5. And actually, if we were kind of working with how I did things yesterday, I would go something like this. And this works too. So I can take the square root of -1. It gets replaced with I. So I times root 5. And I can't do anything with the root 5 because 5 is not a square number. And I cannot break it down into any other factors that are square numbers. So that is the simplest form of the radical that we can get. All right, -80 now. Let's go ahead and break down 80 into, what can we break 80 down into? So I'm going to go ahead and work on it maybe up here where I got a little bit of space. So let's make some factors of 80. So that's 1 times 80, 2 times 40. I cannot multiply anything. I don't think I can multiply anything by 3 to get 80. So I'm going to skip that one and go to 4. 4 times 20. And so far, I have not reached any square numbers. 5 times 16. And actually, 16 is a square number, which is why I had you memorize the numbers that make square numbers. So I'm going to go ahead and take the square root of 16 and multiply that times the square root of 5. So again, I broke it down into 5 times 16. But since I can take the square root of 16, I'm going to go ahead and do that. So square root of 16 is 4, and square root of -1 is I. And we can't do anything about this 5, so it's going to just stay in there. All right, moving on to -32. Let's see, -32. So that's going to be, well, we need square numbers. But let's take out that negative first, because again, -1 times 32 is a way to separate the -1. And let's see, 2 times 16. So I'm going to go with 16 times 2. All right, so -1, take that out, we get I. And take the square root of 16, we get 4. But we cannot do anything about this 2, so I'm going to go ahead and leave that out of there. Leave it in the radical, so we cannot do anything with that. Okay. And again, here I have two different ways of doing it, and you can just pick whichever way makes more sense to you. All right, let's go ahead and move on to number 6. Let's see, definitely -1. And I need two numbers that can multiply to -100, or actually in this case, we took out the negative, so just 192. So what numbers can I multiply to get 192? So you can always break it down into a factor. So I'm gonna factor it out. So let's see, half of 192. What is a half of 192? That would be 96. And I'm gonna break this down into 2 times, let's see, 45 plus 3, that would be 48. And break down 48 into 2 times 24. And 24, break that down into 2 and 12. And 12 is made from 2 and 6. And 6 is made from 2 and 3. Ooh, that's a lot of factors. So count how many you have. 1, 2, 3. So I have 3 sets. And what you can do is, I'm going to put these back together. So that's going to be 4 times 4 times 4, because we haven't taken them out of the radical yet, times 3. And I could even put these back together to make 64, so I can take the square root of 64, but I'm just showing you another way you can do this. So we got I, well, okay, square root of 4 is 2. This here is going to be 2 again, and square root of this 4 is going to be 2. And this is going to be I, because I'm just going to take this here, the square root of -1, and that's going to be I, and root 3. So I cannot do anything about this 3, so it's going to just stay in there. And let's put these back together. So 2 times 2 times 2 is 8. I root 3. And that's the using factoring method. So I completely factored the number, look for the sets, and take those numbers out. So again, 2 times 2 times 2 is 8. So there we go. Looks like it's going to be it for that one. And moving on. Solving equations. Now I need a number that I can square and add 81 to get 0. Well, if this was able to be -81, -81 plus 81 would be 0, but we can't really get that. So let's use the rules we used yesterday. Isolate x as much as we can. So I am going to minus 81 from both sides. So x squared equals -81. And now you notice that we're kind of running into a bit of a problem here. Because if you remember, any number you square is automatically going to become positive. So what could you possibly put in there to make -81? Again, 9 does not work because 9 times 9 is positive 81. -9 times -9 is still positive 81. So there isn't really much that we can put in there. Now, yeah, okay, so you might be saying there's no solution, but that's kind of true, but it's not really no solution. It would be no real solution. And I know that's kind of confusing, but bear with me here. So square root here, square root there. X equals positive and negative. All right, and we can take the square root of 81, and that would be 9. And remember that we're going to take out this negative on its own as well. So that would be 9 imaginary. All right, now for this one, I said I was going to try to show you as best I can, and I'm not really sure if this is really the way, but I'm going to see if I can explain this a little better. So I'm going to go over to the graph, and let's type in what we got for number 7. So that would be x squared, we get a parabola, plus 81. Okay, now we have a parabola, but you notice that it is not intercepting with the graph, with the x-axis. Remember, that's the solution. The solution is where it crosses the x-axis, the x-intercept. That is our solution, but there's no solution in this case. Okay, now this is kind of again, a weird way of thinking about it, but what if I were to make it negative? Oopsie. Let me go ahead and get rid of this. Oh, there it is, negative. So I'm going to make it negative. And you notice that now it's facing in the opposite direction. So I'm going to go ahead and switch back and forth between the negative. And you notice that it's mirroring right where it needs to go. Now, if I leave it like this, that's not the equation. You notice that it is crossing at -9 and +9. So you can kind of imagine it like this is the original, and there's no real solution because it could be a real solution, but it's facing the opposite direction. And again, I'm not sure if that really makes a whole lot of sense, but if it was imagining going the other way, then it would have a solution. And sometimes you can turn imaginary numbers into real numbers. So that's why we don't just say no solution. That's why we don't just stop there. So in math, sometimes we need to keep going. We need to keep going with our calculations, or sometimes something can change and we can get a real solution down the line. All right, so let's go ahead and solve number 8. All right, -9 from both sides. And I got to get that 2 out of there. So x squared equals -4. And again, we get what would otherwise be a pretty easy one, but it's going to be made complicated because of that negative. So x equals, and this is going to be -1 times 4. We can take the square root of 4, which is 2, but the negative is still in there. So we're going to take that out because, again, the square root of -1 is I. So I'm just replace that. Oh yeah, and don't forget this thing here, because there are 2 solutions, a positive and a negative, and this still counts if one of them is imaginary anyway. So I'm going to go back over to our up here. So go ahead and type in 2x squared, and let's see, it would be +9, but remember we had -8, so I'm going to add 8 to both sides, and we have another instance of the graph kind of being in the wrong direction. But if I make it negative, it will cross at 2 and -2. But it's not actually going to cross because it's actually facing upward. Yeah, and that's about the best I can do for an explanation. All right, let's go ahead and move on to the next one. Okay, and let's see. We got to solve this one now. -15 minus 15. Negative, that's going to become negative 24. And I still got to isolate this x squared, so I'm going to go ahead and divide both sides by 4, canceling the 4. X squared equals negative 12. Oh, wait a minute, hold on, that'd be divided by 2. It would actually be 6. And once we have it isolated, let's go ahead and take the root of both sides. So x equals, don't forget your plus and minus. We are going to take out the negative, so that is negative 1. And we can't do anything for 6, right? Because the only two factors I can use to make 6 is 2 and 3, which neither of those are square numbers, so we cannot take it out. And that's about as simple as we can get it. So that's going to have to be our answer this time around. All right, so moving on to the next one. Okay. All right, start by getting this x squared. So that means you got to move this 13 out of here. So do the inverse. Remember, inverse means like the opposite. Well, technically it means the backwards. Like reverse, but maybe not so much the same. Anyway, here we get negative 12. Okay, now it's isolated here, so I'm going to go ahead and take the root of both sides. And think of two numbers that multiply to 12. 4 and 3, where 4 is a square number, so x equals positive and negative. Take the square root of 4, we get 2. Square root of negative 1, we get I. And 3 stays in there, so we can't do anything about that. So just go ahead and leave it in there for now. And it looks like we are done with that one. All right, moving on to the next one. Continue solving. And again, with these solving, you just do it the same way you would with any ordinary algebra problems. Anything algebra, just do the same thing. And let's see, 446 minus 5 would be 441. And since the number on the negative is bigger, that's going to make it negative. All right, now we got to get this 3 out of here, so I'm going to divide both sides by 3. X squared equals, negative 147. Just divide that. All right, now it's isolated. Let's take the root of both sides. So root here, root there. X equals plus and minus, and now I need two numbers that multiply to 147. Or let's see, what can I do? Well, actually, let's go ahead and just work with only 147 for now. So let's see, 147, I can't divide it by any even number, so 2 is out of the question. Let's try 3. 3 times 49. And 49 is a square number, so let's go ahead and use that. So negative 1 times 49 times, and we have a leftover of 3. And let's take out what we can from the radical. So, that square would be gone. So x equals positive and negative. Square root of 49 is 7. Square root of -1 is I. And 3 stays in there. And I don't think there's anything else we can do with this, so I think we are going to go ahead and call this one done. And leaving us with only number 12 for this exercise. All right, so same thing, let's do our adding and subtracting first. -2/3 x squared equals 18. Now you could do this one at a time and multiply both sides by 3 and then divide both sides by -2. But I'm gonna kind of do a shortcut here and I'm gonna multiply both sides by the reciprocal. We need the reciprocal because this is the multiplicative inverse. But reciprocal would mean that we reverse the numbers in fraction. So instead of 2/3, we get 3/2. We also want to get rid of the negative, so I'm going to multiply the negative as well. And whatever I do to one side, I should do it to the other side. Now I'm going to just make this a little bit longer here so I can include more things in here. Now the reason why this works is because -3 times 2 is 6. 2 times 3 is also 6. 6/6 equals 1. Okay, that is one of the properties of division. Any number divided by itself is going to equal 1. 1 times x squared is just going to be x squared because of identity property. All right, I'm going to multiply this out, 18 times 3, and that is 56/2. But it's also going to be negative as well. And 56 divided by 2 is going to be 27. Root both sides here and there. X equals, we don't have the square anymore, positive and negative, and I'm going to have to do a little bit of factoring on 27. Actually, I could probably do that right here. So 27 is made from 3 times 9, which 9 is a square number. So take the square root of 9 and we get 3. We also have a negative in there. So to take that negative out, we're going to have to replace it with I. And we leave 3 in there. So we cannot take this 3 out, but we can take the 9 out. Because 3 is not a square number, but 9 is a square number. And there we go for that one. All right, next thing. The powers of I. So here, if we look at this chart, I got I to the 1 power, I to the 2 power, I to the 3 power, I to the 4 power, all the way up to 8 power. Now, normally I would make this lesson all on my own. What's that?
Can you go to the slide before?
All right, so powers of I. All right, so we know by definition, I to the 1 power, or just I, is the same thing as root of -1. I mean, that is the definition of it. And we know that in this case, anything to the 1 power is that same thing, so we end up with I. All right, now again, these are kind of tough, and I don't know, I wouldn't want to derive these, meaning basically do the calculation every single time to get them. But yeah, sometimes you just can't keep this list around, which again, normally I would save this for its own lesson, but here it's combined with this other stuff here. So I'm gonna just keep it that way. So -1, right? Because we got I, but here it's squared. So if I square it, well, remember that the root and the power are opposites. They will cancel each other out. If the root and the power cancel each other out, that will leave me with only -1. There we go. That is the next one. Now we have I to the 3 power. Whew. Now, I can break this into factors of I. So I2, or I square, I should say, times I to the 1. We know that I square equals -1. So I'm going to go ahead and put -1 times I1. So I to the 1 power here is just I. Anything to the 1 power is that same number. Now I'm left with -1 times I, so that should be -I. All right, now time for I to the 4. So if I have I square times I square, that will give me I to the 4. The reason I chose I square is because I know that I square is equal to -1. So this is just like saying -1 times -1. And we know -1 times -1, negative times a negative is positive. So we end up with +1. All right, so let's see what we get for I to the 5th. Now I'm going to use I to the 4 because I know that I to the 4 is just 1. So I to the 4 and I1, so if I add the powers, that would be I to the 5th. Now again, I to the 4 is 1, comes out to just plain old 1. I to the 1, right here, I1 is just I, and identity property says that anything times 1 is going to be the same number. So in this case, I just get I. All right, now I'm going to go ahead and move over to I to the 6, which I'm going to try to explain it in terms of I to the 4 again. Because in this case, it's very useful because I to the 4, again, just means 1. Timesing things by 1 should be one of the easiest things you do. So here I got I square, so times it here. I square is actually -1. So this means 1 times -1, which is -1. Okay, now I to the 7. Now, if you look at the power here, 1 power, 2 power, 3 power, which the powers combined would make I to the 7. So I to the 4 is 1 times I to the 3, which is I to the 3 is, looking at this line, it would be -I. Oopsie, I said 1. I don't know why I wrote 4. 1 times -I. And that would just give us -I. And you probably notice the columns are the same. They are pretty much identical. And that's because this pattern repeats itself every 4 powers. So I to the 4 is 1, and I to the 4 here is also 1, and 1 times 1 is 1. And again, that's a good way to kind of remember this. Now, again, I know it's going to be kind of hard to remember this. So you're probably going to have to keep a chart of this on hand for future assignments, which I think we only have one more assignment for complex numbers. There's a little, I think they do show up a little bit every now and then, but this would be very useful to have for your own reference. So let's use this pattern to simplify. So we could break it down into numbers like this. So make sure the powers add up to 15. So I to the 4, that would be I to the 8. One more is I to the 12. But to get 15, I'm going to have to multiply it by I to the 3 here on the last one. So the powers will combine to make I to the 3. And let's see, I to the 4 is 1 times 1 times 1 times I to the 3. And if we look at our chart, I to the 3 is just equal to negative I. So I just need to put negative I there and we are done. All right, now this method works out if your number is small enough to where you can get a good number of I to the 4 powers. But in this case here with 62, we have a lot of 4 powers in there. And there's no real telling how many we have to do. There is kind of a shortcut, but it is complicated. So try to follow along here. Now we know this pattern repeats every 4 numbers. So we need to know which one of these 4 it lands on, basically. So I'm going to divide it. Take the power and divide it by 4. Now again, remember, this is going to take out 4 each time. So 4 goes into 6 one time. And that's going to be 2 here. So I'm going to go ahead and move this down here. 4 goes into 22 5 times. Now, when you divide normally, when you're doing normal division, this is what you're interested in. However, today, we don't care about that. Completely throw it out. We don't need it. We are not looking for the quotient. We want to know what the remainder is, because the remainder will tell us which of these 4 we are looking at. And let's see, keep going, because now we will see our remainder is 2. So what this means is it's the same as I to the 2. So look at I to the 2, and we get negative 1. So the answer is negative 1. Now, it's always going to come out to one of these 4. Okay, it's always going to come out to one of these 4 possibilities, either I, negative 1, negative I, or positive 1. Those are the only 4 options you can get with something like this. So if you get something else, better check your work again. All right, moving on. All right, last of the objectives. Products of pure imaginary numbers. All right, so here I have 4i times 7i, and that should be pretty easy because whenever you have something like this, like I is just a variable. If I said 4a times 7a, you would not hesitate to know what that would be, okay? You would immediately say 28i square. So again, the I behaves like a normal variable. However, there is one exception. That exception is that here we have I square. Looking at the chart, I square is equal to negative 1. So 28 times negative 1. I'm going to substitute it in, switch it out. And now we just multiply this together and we get negative 28, and that's our answer for this one. All right, let's go ahead and multiply these three out together. And you can put them in order, so negative 4 times 2 times negative 9, if that helps out. I to the 3, because I have 1, 2, 3 i's. Multiply out the coefficients, so this would be negative 8, right? These first two will make negative 8. Negative 8 times negative 9, which a negative times a negative would be positive. So that would be positive 72i to the 3. And again, for I, it does not end here because I to the third power is negative I. So 72 times negative I. And that's just like, again, multiplying it times any other variable. If this was 72 times negative b, that would be a lot easier to understand, but it would be negative 72i. And it looks like it's it for that. So let's move on to the next one. Oh boy. 2i to the third power. Now what you should do is write it out by expanding the entire thing. So when you have a 3 power on a group, that means you have 3 of those pieces. All right, so 2 times 2 times 2 is 8. I times I times I is going to be I to the third power times 5i. And I'm going to multiply these two together. So multiply the numbers. 8 times 5 is 40. Combine your powers of I, so that'd be 3 and 1, so you'd have a 4 power I. And let's go back to the chart and see what I to the 4 power will become. I to the 4 is 1, just plain old 1. 40 times 1. And that makes our final answer 40. Okay, number 18 now. All right, now in this case here, since I have two kind of terms, I can also kind of like distributive, but I don't like saying that because sometimes it's a little bit more complicated than that. But I'm gonna make both of these 2 power, so I square, and I'm also gonna square 3. So 3 square is gonna be 9. And I'm gonna expand this one out as well. Okay, so take the square root of 9, we get 3. And here, I square, we get negative 1. And now we got to do the same thing to this side. I'm going to multiply it out. So negative 8 times negative 8 is 64. I square. All right, multiply that, that'd be negative 3. And here we have 64 times I square, which would be -1. And now I need to multiply them together. Oh, wait a minute. So that would be -3 times -64. Negative times negative is positive, and that would be 192. All right, and we're done with that one. Off to the last one. Okay. So no eyes. Well, we can't really see the eye just yet. So that's the first thing we're going to do is take these out. So that's going to be I root 18, because again, we took the negative out, so the negative comes out. Here, take this out again. Multiply the I together, so I times I is I square, times, now neither 18 nor 10 are square numbers, so this would be 180. Now I need two numbers that can multiply to 180 that are square numbers. So think of a square number. We could try 4. Let's see, that'd be 4 times what would be 180? That'd be 45, which, okay, that might work, but we don't have a big enough number. Let's try maybe 16. I don't think 16 is going to work out either, actually. What we could do is try 36. 36 times 5. And this looks like the combination that we're going to need. So I'm going to go ahead and replace I square with -1 times root 36 times root 5. We can take the square root of 36, and that would be 6. 6 times -1 is -6. And that's about as simple as we can get it, so that looks like that's the answer. All right, now we have 3 numbers being multiplied. And let's do the same thing. Let's take out the I on all of them. So that'd be I times the root of 24 times I times the root of 3 times I times the root of 2. So we took out the negatives, and that makes it kind of easy. So now I have I times I times I, which would be I to the 3, times, oh boy, what am I going to get here? 24 times 6. 24 times 6 is, oh, not so bad, 144. Now looking at the chart, I to the 3rd is going to be -I. So -I times square root of 144 is 12. So, well, -12I after I put them together. And there we go. But that is it for today. There is nothing else. So I'll be around if you have any questions. If not, then I will see you later. All right, bye now.